Welcome to Dr. J's Java modules. In this module, we will look at an introduction to object-oriented programming. All right, so let's see what we've got on the agenda today. We have the three primary principles of object-oriented programming, which you should memorize, especially if you're one of my in-person students and expect a good grade. So, the three primary principles of object-oriented programming are encapsulation, inheritance, and polymorphism. I would recommend learning them in that order because each one builds on the previous one. So, encapsulation, inheritance, and polymorphism. You should be able to spout that out very easily if anyone ever asks you. Now, some different authors and different educators say there's 4 principles, and they might include abstraction, but I think these 3 actually cover abstraction as well. So, encapsulation. So we should know what these are and what they do. So what is encapsulation? We encapsulate data and behaviors. That's what we're encapsulating, using fields and methods. So why do we do this? Like, what does encapsulation provide us with? Well, it provides us with security and portability. So you need to know that. So we encapsulate the data and the behaviors, and that it provides security and portability. So what is security? What do we mean by security in this case? Security has many different definitions, many different facets, and entire people spend their entire majors talking about security, and some people are professionals at secure software engineering and things like that. So what do we mean when we're talking about it providing security? Well, we're talking about the fact that it protects modification of internal data, and that causes us to have program state, the internal data. So if you ever hear anyone say the state of a program or the program's state, they're really just talking about the different values that all the different variables have at any given time. Like if you took a snapshot or a picture in time of what the different variables look like and what their values are, that is the program's state. So it protects modification of internal data from the outside in an incorrect manner. So we're really talking about the enabling principles also of information hiding and implementation hiding. So if you ever hear of information hiding, that is an enabling principle of encapsulation. We're hiding and protecting the outside world, or rather protecting our data from the outside world's modification, except through a well-defined quote-unquote interface. We have to be careful using the term interface because there is actually a thing called an interface in Java. So besides security, we also have portability, which encapsulation provides as well. We can create an entity that does many different things, and including tracking many different pieces of data, and we treat this entity as a single collective unit that we can move around as an individual unit. So before object-oriented programming, if you had to represent a person, and that person had a name, a height, a weight, and say an employee ID, that's just 4 pieces of data, and that would mean like 4 parameters you'd have to pass around different functions or methods in the case of Java. But what we get with this object orientation is we get to put all that stuff inside of a single object, and that single object represents an individual. And you might even have an array of objects, which increases it even better. So if, let's say, you have an array or an array list, those themselves are objects, but they're containers. They're data structures that hold other object references, rather. And if you can hold like 150, 500 different references to employees, let's say, that's one object. You're representing 500 individual objects, and each of those may have 4 or 5 or 10 or 20 or 60 different attributes to them. So portability is very important. So involved in encapsulation are classes and objects. So a class acts as a blueprint for an object. An object is what we call an instance of a class. Now, some people just rattle that off when they're asked and they don't really think about it. What does that mean? Well, if you look at a particular concept of, say, an orange, like the fruit, okay? So I have a concept of this thing called the orange, that could be like the class. That would be saying this is what an orange is, this is what it does, this is how it tastes, this is the family it lives in, this is the type of flavor it gives off, and it's got this sweetness and this, sourness in some cases, and this range of flavors and all this other stuff. That would be kind of the class that acts as a blueprint. When I hand you 2, 3, 4 different oranges, what that's saying is, hey, these are different instances of this orange. Now, one of them might be riper than another, one of them might be sweeter than another, etc. So that's the idea. Class acts as a blueprint for an object, and an object is an instance. So I'd say, here's an orange, for instance, and I could hand you that instance of the orange class. Now let's create a rectangle class. I have the NetBeans fired up already, and I have a project module OOP intro already created. So let's go in here. I'm actually going to create 2 classes. One will be to test it out. So I right click, go to New, Java class, and then Rectangle. And then I'm going to create another one. Right click the default package, New, Java class, and I'll call this one Rectangle Demo. So the demo will house main, and then the rectangle will actually represent the rectangle. So we've got public static void main, string bracket args. There we go. So I've got that set up to use the rectangle once we're done with it. Inside here, in the rectangle class, we will not have a main. Now, Java would allow you to create the main inside this class too, but it's not really good to do that, in my opinion. So you should keep the entities that you are representing separate from where the main method is. So in most cases, not all cases. But what do we need to represent a rectangle? So we would need a length and width. So since these are at the class level, directly inside the class, they're the closest thing Java has to, quote, global variables. But they're more akin to, if you're from C++, they're more akin to just private data members. They're called fields. And specifically, these are instance fields, because each rectangle object will get its own copy. You'll notice that there is no static keyword here, okay? Like we have a static keyword on main. There's no static keyword here. Static means it's owned by the class, not a particular object. Whereas if it's an instance field or instance method, it's either physically or logically owned by the object, not by the class. So if you have a rectangle and I have a rectangle, my rectangle's length and width do not have to be the same as yours because we each get our own copies. Now we also have constructors. So this would be, there's one constructor. This is the no argument constructor. And then we have another one, double length, double width. There's a parameterized constructor there. And the constructors, as you probably know, are called immediately when a rectangle object is created. So this one, you may have heard the term, and it's used very frequently in even in industry, but it's technically not true. You've heard it called the default constructor. Okay, so that's actually a little bit of a misunderstanding, but pretty much I'd say probably the majority of people, including professors, still seem to think that's what this thing's called. But it's really not the default constructor. The default constructor is since every class needs a constructor, if you don't provide any of them, the compiler provides one without any parameters. So that we call it a no arg or no parameter constructor. Usually just no arg for no argument constructor. So if the compiler provides the no arg constructor, and you won't see it in the code, the compiler just provides it behind the scenes when you go to create instances of your class. If the compiler provides it, then that is the default constructor. But if you write it, there is no default constructor, even if you don't put parameters here. What you're writing is a no argument constructor or a parameterless constructor. Okay? And then down here, we've got this second constructor. It's an overload because it has the same name. Just like any method, it's called an overloaded method. In this case, an overloaded constructor because it has the same name, but it has a different parameter list. Also notice the shortcut terminology here, syntax. It's not really syntax, but the shortcut CTOR for constructor. So if you ever see that, some people actually use the term inline in different textbooks and journal articles. They'll say, if you write out your CTOR, do this, this, and this, and you might look at it and think, what the heck's a CTOR? Well, it's a constructor. So that's what that means. So for this one, let's do this one first, actually, the parameterized constructor. And you might think, well, wait a minute, why did you pick length and width as the names of the parameters? So because if I do this, if I say length equals length, that's a little confusing. It says the assigned value is never used and assignment to itself. So you'll notice color code wise, the IDE is trying to give you a hint. You'll notice that it does not turn green because it is not thinking it's the field, which we should be setting. It thinks it's the parameter. So the ways you can get around this is you can either make this name different. I can create that as len, and then you'll notice this one turns green. That's one way to do it. However, that's a real crappy way to do it, in my opinion. The reason it's crappy is because this isn't so bad, like len and wid. Number one, what's one of the rules about coming up with identifiers? And that goes for fields, that goes for parameters, that goes for local variables, doesn't matter. You should come up with good names for your identifiers. So what does that tell us about len and wid? Those are bad identifiers. What if you use L and W? Well, L looks like a 1, so that's stupid. Single letter identifiers are usually not particularly good unless you're using them in, say, math, like XYZ, or maybe I equals 0 in a for loop, or J or K. Those types of things fly, but a lot of the stuff don't. Like, a lot of these things don't. So even though in this case it's not as bad, this is even worse. I will immediately fail you and send you back to 3rd grade if you do this. I swear my eye is going to pop out of my socket. If you're one of my students and you do this, I'm not even going to grade it. Seriously, don't do crap like that. That's just evil. Okay, my recommendation, my strong recommendation, is you make them the same name, but you can overcome this problem because it thinks this is the parameter. So the question is, how do you get to the field, right? So you do this. You put this and a dot. Now, in C++, you would put an arrow, but remember, in Java, we don't have pointers, but we do have reference types. And this is a reference type holding the address of the current object in question. It's actually, you might think, where does it come from? Well, it's passed in, technically, to the method. Even though we would say, hey, this constructor has 2 parameters, there's actually an implicit parameter that's a 3rd parameter. But if you're ever asked in an interview, how many parameters does this have? Don't say 3 or 4 because of this and super. You're going to say it's got 2 because it's length and width. So this .length overcomes this problem. Now, what is this problem called? So if you're ever asked to articulate, what is the problem called that causes the inside of the method to not be able to see the fields because it's got the same name as the parameter has the same name as the field, and that overcomes name shadowing. That's what that's called, shadowing or name shadowing, or identifier shadowing. Same thing with width. I recommend you do that for any number of parameters. And for, again, rectangle, it's not that bad. If you came up with len and wid, people would know what you meant, but it's still better this way. But let's assume that you have 16 different fields that you have to set through a constructor. You're going to come up with not only the 16 field names, but then 16 additional names. I don't want to do that. So why don't you just overcome name shadowing like this? I would recommend the same type of practice in other languages like C++. Just put this arrow length, this arrow width, and you're good. Now what do I do here? So what do I do with rectangle here? Now I could put length equals 1. Let's say we want it to be the unit square. I could put length equals 1, width equals 1. I don't have to put this in front of it. I could, but I don't have to, because there's no name shadowing. There's no parameter here to shadow, right? So that's one option. The other option, which is arguably in this case the better option, is if you use the this keyword, it's actually quite versatile. Right now, if I put a dot, it's being used as the object itself, but you can actually pass in stuff like this, and if we're to be total, even though it'll work, if we're to be totally correct, doubles, two doubles, what it's going to do is it's going to look for another constructor, and you can only do this in constructors. Now you can use the this keyword in other methods that are instance methods, but you can't use it like this. So this right here calls another constructor, and it looks for a constructor with two doubles, because I'm passing two doubles to it. And it looks down here and finds this, and this one actually takes care of it. Now you might think, well, what do I get by that? I'm only saving like 2 lines of code. Well, yeah, in this case. But what if you're doing like a ton of checking right here? Like I could put a bunch of if statements, and in fact, if it was industrial level code, I would put a bunch of if statements around these and say, make sure the length is at least 0 or at least 1 or at least, greater than 0 or something like that. I could do stuff like that. And if I did that, I would really only want to do that in one place. So this does actually help. And by the way, if you have to call, let's say I extended general shape or some other class, and I wanted to call my parent instead of my own constructor, I would want to call my parent's constructor, I would put super. So I would put super and then call something like that. Good? All right, so that's it for that. Now, the next thing would be I want getters and setters for length and width. And since I'm assuming you all have some decent level of ability with classes at this point, you know that what a getter and a setter looks like. There's actually a shortcut in NetBeans that I want you to make you aware of at least. If you right-click, put the insertion point right here. Mr. Blinkham's right here is the insertion point. If I right-click here, and I go down to, there's a couple ways to do it. If I go to Insert Code, and then I go to Getter and Setter, I can actually pick getters and setters for both length and width, or whichever variables you have, fields you have. You click Generate, and it will actually create all of the getters and setters for each one. So getLength is a getter or an accessor. So this is an accessor, get length, right? This right here, setLength, would be a mutator, right? Because it changes things. SetLength is a mutator. This one in this case does not return anything, and it just takes a parameter if I wanted to change the length once the object was already created. Now, if you wanted a situation where you could only get the width and the length and you wanted to remove all the setters, meaning once the constructor is called and once that length and width is set with the constructor, I don't want the user to ever be able to change it again, then you would remove all the mutators. What that would do is what that would change your class to is a class that is immutable. So that's what it means when you lack mutators or remove all the mutators. It's immutable, lacking mutators. Pretty cool, huh? So with mutators, we say that this class is mutable, meaning you can mutate it, right? Now, it'll generate those, which are pretty simple, getters and setters, but you have to come up with the logic on a lot of these. And if you want to do any like reinforcement of ifs and things like that, or if statements, then you would put it around the code in here and there. Now, here's another thing. What if I want the area? So public double area. You could put get area if you wanted, but we'll just go with area. This is the area method. Okay. And this is pretty easy, right? Length times width. And then you could also do perimeter, right? A couple ways to do this. but we'll return 2 times and then length plus width. Pretty good there. That's the end of perimeter method. And you could do all kinds of other stuff. Now, if I want to make it more complicated, I could set a color. I could do all kinds of other stuff to represent this rectangle, depending on how complex your application is. But in this case, we're pretty good. That's all we need. Let's go over to Rectangle Demo. And in Rectangle Demo, I will create Rectangle R1. And I'm doing this on purpose. Give me a second. And then we'll do Rectangle R2 equals new rectangle, let's say a 5.0 by a 10.5. And then let's do this one, rectangle R3 equals R1. So let's think this one through for a minute here. What's actually happening? Have I created a rectangle object by this line? Did I create a rectangle object? And the answer in Java is no. I have not created a rectangle object. I've created a reference variable capable of holding the memory address of a rectangle object. I create the rectangle object right here. So new is an operator. It is a unary operator. It takes one operand, the constructor of a class, and it returns the value to whoever's listening. And in this case, on the left side here, left-hand operator, or operand rather, left-hand operand on the assignment operator is R1, and that grabs the address that is returned by the new operator with the constructor. Pretty cool. Right here, we did it all inline. So you have the declaration and the initialization to the rectangle object. And then down here, am I copying the rectangle? So what am I actually copying? Am I making a copy of the rectangle? The answer is no. I'm making a copy of the value that's in R1, and that is not a rectangle. That is an address of a rectangle. So that means R3 and R1 are just pointing to the same rectangle in memory. So if R3 changes the length, R1 will reflect it. Okay, so let's print out some data here. Let's say R1.area. Let's do this. So we'll say R1 area. R1.area, and then we'll do R1 perimeter, R1.perimeter, not protected, that's silly. R1.perimeter, there we go. We'll do the same thing with R2. So R2 area, and then also R2 perim. All right, there we go. Let's see what happens. Now, if I run this rectangle demo, you will see, after it warms up a little bit here, first run for a while. There we go. I have the R1 area is 1, because remember, we use the no argument constructor, no arg constructor. So that gives us a 1 by 1, which is area of 1. The perimeter would be 1 on 2 of the sides, each of those sides, and then 1 on the other 2 sides, and it's a square, so it's 1, 2, 3, 4. And then we get 52.5 and 31 for the other area and perimeter. So we've got these areas, perimeters, area, perimeter. Pretty cool. Now, what happens if, since R3 and R1 are pointing to the same thing, what happens if R3 set length to, we'll say 100, and then we'll say R3.set width to 20, and then I reprint out the area of R1. Let's see what happens. So run that. And you'll notice that R1 was indeed affected. Even though I did not explicitly change R1, remember these are references. These are not, even though they refer to and represent the object, these are not the same thing. So we were able, in fact, to change the length and the width of R1 through the variable R3 because they both refer to the same object. Okay, it's hard sometimes to keep in sight that these are holding addresses because you're interacting with them by calling methods and doing things on them like area and perimeter, and you're like, oh, well, of course it's an object. At the end of the day, Java knows that when you use it with a dot, that you're wanting to access the object, but when you use it with things like an equals sign or you pass it into a method or something like that, you are using it as an address. Okay, so ultimately it's an address. All right, pretty cool. So, instance versus static. Methods and fields can be instance, which is the default, or they can be static. Static fields and methods are designated with the static keyword. So instance, as we mentioned before, each object gets its own copy. Only instance methods can use the this keyword because it doesn't make sense inside static methods. If the class owns the method, then which object are you talking about when you say this? That's why you can't use it. So static, again, is the class owns the sole copy, and it can exist with static fields and methods exist without any objects existing. And if there are objects, they all share the same copy. Let's add num rectangles and get num rectangles to our class. So over to rectangle, private static, num rectangles. Another thing to mention about, I guess that's int num rectangles. So we got the use modifier, but we need the data type as well. You notice it italicizes it in the IDE because it recognizes it as static. Another thing to note about fields, whether they are static or instance, is that they get the default 0 value for their type. So the primitives, such as double, get 0.0, ints would get 0. If it's a reference type and it's a field, whether it's static or instance, a reference type will get null. So what do I do to access this, or what do I do with it? And the answer to get it, I can do this. I can say public static int get num rectangles and just return num rectangles. Awesome. Pretty easy, right? So that's pretty simple. So that's to get the number of rectangles. Now, how am I going to count the rectangles? Where's a good place to add a counter for the rectangles? And the answer is here, right? Num rectangles, right? Every time we create a rectangle, we should increment this. Now, should you put another one of those up here, like num rectangles plus there? The answer is no, because if this one is calling this one, it's already counting it. So you'd be double counting any rectangle created with the noArg constructor. And that would be a logic error, right? One of our exciting logic errors. Okay, so we don't have to initialize num rectangles to 0 because it already is. If it makes you feel better, you can do it, but it's not really necessary. And then every time someone asks for the number, they can call get num rectangles. Now, how do we access this and call it? Well, the cool thing is I can do it up here. I can say num rectangles. I'm going to say rectangle dot get num rectangles. And I can call that even before any instances exist. And you'll notice if I run the demo, I get num rectangles is 0. Now, another thing I can do is right between where I declare the variable and create the instance, you'll notice same answer. Why is it still 0? Ah, that's right, because I haven't actually created an instance. I've done what? I've created a variable capable of holding the instance. So I can now, after R1, then it'll say 1, and then after the R2, and even after the R3, how many should it say? Should it be 2 or 3? Let's see. 2. Because even though you have 3 variables, this right here, it's pointing to one object. You didn't create 3 different rectangle objects. So this is giving us the correct answer. Pretty cool. All right. Next up, inheritance. So inheritance in Java uses the extends keyword. So if I'm to do something, I could say public my class extends another class. And in C++, it would look something like this, my class colon, and then the type of inheritance in the other class. The other thing in C++ is you could actually have multiple classes over here because C++ supports multiple inheritance with classes. Java does not. Java allows you to extend only one other class, but you can implement other interfaces, which is something that C++ doesn't have. So really what's interesting is the way you would use interfaces in Java is the way that you should use multiple inheritance in C++ whenever you actually use it. But you should only inherit from one other class. You can only inherit from one other class. This is UML diagram. Not particularly good, but it's simple. So we have a not filled in arrowhead right here, pointing from the subclass or derived class to the superclass or the base class. In Java, we tend to use the terms superclass and subclass. So animal is the superclass, dog is the subclass. Car is a subclass, vehicle is a superclass. Fruit fly would be a subclass, insect would be the superclass. Composition is another object-oriented principle, but it's not considered one of the three primary object-oriented principles. But it is very important and it's used a lot. In fact, composition is often a favored software engineering technique. There's actually the term composition over inheritance. So that says to favor using composition over inheritance. So while inheritance is an is-a relationship, composition is a has-a relationship. So car has an engine, person has a name. We wouldn't say a car is an engine or an engine is a car. That doesn't make sense. So as long as you have a class that has a reference to another class, so my car class has a reference to an engine class, person has a reference to a name class, or even a string class, as long as it's another class, then that means you're using composition. All right. Next we have the concept of abstract classes. So it's one with no body. Now there's a song reference here, and I want to make sure that everyone knows this song, because you can't see me do it. So if we play it right here, then you should be able to hear it. And it keeps going, and then eventually it's from Young Frankenstein. Ain't got no body. So this is my famous song that I sing to my students. And unfortunately, because of the pandemic, we aren't getting you aren't getting the excitement of watching me do jazz hands while singing it. So anyway, an abstract method ain't got no body. So it doesn't have a body. So you'll notice it has the header, public void do something, or public boolean, or public int, or public array list, or whatever, and then whatever the signature is right here. But you'll notice that there's no body, not even an empty one, right? So it's a semicolon. Now that's an abstract method, okay? In C++, we would call that a virtual method, right? An abstract class cannot be instantiated, or rather, I'm sorry, in C++ you would call it a pure virtual method. In C++, it would use syntax something like void do something, and then you'd have this special syntax right here to indicate I don't have a body, but you have to put that on the end. Virtual void do something. That's a pure virtual function so pure virtual method in C++, right? So that's approximately equivalent what they are. So it's an abstract method in Java. An abstract class cannot be instantiated. An abstract class's purpose in life is just to serve as a superclass, so base class. It can have abstract methods, but it doesn't have to. So you can label a class, you can put public abstract class, and you don't have to have abstract methods in it, but you can. If a class, though, has at least one abstract method, it has to also be labeled as abstract, because it would not make sense. The purpose of an abstract class is to serve as a superclass, and you can't have an instance of an abstract class. Like I can't say, if I have an abstract class animal, I can't say animal A equals new animal. That doesn't make sense, right? So if animal is an abstract class, animal equals new animal, that's an error. But I can do something like this. I can say animal doggy equals new dog, assuming dog inherits from animal and is not abstract itself. So remember, you can't create an instance of animal directly, but you can use it as a reference type. Again, this goes back to the importance of understanding the difference between a reference variable and the object that it's referencing. So, you can have a reference variable of the abstract type, but you cannot instantiate it directly, right? So, the doggy variable above is called a polymorphic reference. So if you're wondering what polymorphism is, this is part of it. So interfaces. A common job interview question, especially if it involves Java, is explain the similarities and differences between abstract classes and interfaces. You can use the interface keyword instead of class in Java, and what it does is it can be inherited from using the implements keyword instead of extends. And an interface has no implementations at all. In other words, it can't have any concrete or non-abstract methods. So, you don't actually have to label them as public or abstract, because they already are. You just put the signature as an abstract method with no body, ain't got no body, and that's the difference between an interface and abstract class. An abstract class can, but doesn't have to, have abstract methods. Neither can be instantiated, so they have that in common. The abstract class can, but doesn't have to have abstract methods. An interface can't have any non-abstract methods. It has all abstract methods. All right. Now, we've talked about encapsulation and that it provides security and portability. We've talked about inheritance, which is the second primary principle of object-oriented programming. And the third is the one that even a lot of industry pros have trouble articulating sometimes. This is polymorphism. So let's say animal is not abstract for the moment. And let's say animal has a make noise method that outputs grr to the console. Let's say dog has an override for make noise that outputs woof to the console. So what are my possibilities? If animal's not abstract now, I can actually create an instance of it, and it can still act as a base class. Animal.makeNoise will go grr. That makes sense. If I create a dog that inherits from animal and say new dog and say make noise, it'll go woof. If I say animal doggy equals new dog, now here's where it gets a little confusing. Since a dog, because of inheritance, a dog is an animal, I can point to or reference the address of the dog object through an animal reference variable. That is a polymorphic reference. And here's where it really comes down to some serious questions, is when I say doggy.makeNoise, the reference variable is type animal, the object is type dog. Which one does it do? There's two different implementations. One that goes grr, one that goes woof. So which one does it do? Right? So I think that has too few R's. There we go. So only I would notice things like this. But anyway, which one doesn't it, or which one does it do? Does it go grr or woof? And that comes back to binding. So if I say animal doggy equals new dog, doggy.makeNoise, the answer is that since Java uses late binding or dynamic binding with anything that's non-private, non-final, non-static, because if they are private, final, or static, any combination of those or alone, private, final, and static members in Java use early binding, but anything that it isn't a private method, isn't a final method, meaning if it's a final method you can't override it, or if it's a static method owned by the class, then those are early, but if it isn't any of those, it uses late binding, which means binding, if you'll recall, is the association of the method call with the method definition. So this means the method call for make noise is associated or bound to the make noise definition at runtime. So it's bound to the object, not the reference. So doggy.makeNoise will go woof in Java. If it were C++ and you put doggy arrow make noise, it would go grr, because C++ uses static binding or early binding by default. Now, how would we change that behavior in C++ if we want to use the same type of behavior that Java uses with late or dynamic binding? And the answer is you would mark it virtual in the base class. Then, if you did that, it would wait until runtime to do the binding, and then it would go woof. Okay, but you have to do special things to make it do that. So these are very significant differences between, say, C++ and Java. So that's pretty much what I have for you. Hopefully you learned a lot in this session, and I will see you next time.